Hey everyone, welcome back to the shop. It's your favorite copyright attorney here with another boring old lame lawsuit review about who invented the pixie wranglers that are modern lithium tool batteries and why a court said it wasn't an obvious improvement on previous technology, why it was patentable. We've been working hard on this one. There we go, look at that. Thank you to Mr. Eevi himself for sponsoring this video. I know we've had our dick in a vice for a long time on this one, but the case only just reached a sort of a closing point, although our loser says they plan to appeal. Yeah, good luck. There's a lot to this one, so I thought we should start with some background. Look here at some of these pixie wranglers and harken back to our doctoral thesis on battery management tragedies. And then maybe we'll engineer our way into a couple of things and see if we can release some magic smoke in the process. So here we are with all our battery accoutrement. There's a lot of different batteries, and that's kind of the point here. I'll start with the ones everybody's kind of familiar with. These guys right here are 18650 lithium-ion cell. There's a like a steel case here, and then inside is the lithium battery chemistry wrapped up in kind of a loop there. You have something similar in these. These are, I think, these are sealed, so that's going to be difficult to get open there without first unsealing them. And then might as well, since I don't have any fingernails. So these are also lithium-ion batteries. These are like 16630s or something. 16340s. And also 3.7 volts. That's the kind of the point of this. The chemistry is all engineered to be the same voltages. This is an RC battery for use in like a quadcopter or an RC car or something. It has a high discharge rate, and this one is 3S, which is 3 series, which means it's a about a 12 volt battery, 11.1 to 12.8 volts. And that's sort of the reason why these batteries are all maybe not the simplest things to deal with. They're very simple from an engineering point, but they're not simple from the layman's point of view. This, for example, is the same size as this one, but they are two different purposes. This is a laptop battery. This is a tool battery. This was taken out of a gateway laptop battery, the red one on the left. This was taken out of a battery pack for the Dyson hand vac. So this is a high discharge battery. This is a low discharge battery. And depending upon how you make the chemistry, you get different discharge rates, different capacities, and different temperatures during discharge. Here are some smaller batteries that are used for little RC stuff, little drones and little cars and stuff. We can take some of these batteries and put them into packs, like you see back here. For hardening the battery against being punctured, you see different options here. The one on the right is simply wrapped up with fiberglass tape and some heat shrink, and the one on the left has a plastic package, but is basically that battery inside that plastic package. Let's see if we can't knock all of those over for you. Only lost one. These are similar. These are a little bit higher capacity, similar size here. You can see, 200 milliamp hours more. I use these big guys over here for building e-bikes. I have no idea. I use these red Sanyo ones reclaimed. I use those for miscellaneous projects. For example, I built, this is a USB battery pack here. This is just 4 3.7 volt cells in parallel. That's what these things are too. When you buy these battery packs, you can sort of tell from the weight where the batteries are and sort of count them. 1, 2, 3. So this would be like a 3-cell battery pack in parallel. This one here, though, is one that I buy these cases from China, and I think there's 8 of them in here. So you put 8 of these 2 amp hour batteries in there, and you have a 16 amp hour pack. And the sort of unprotected nature of the lithium cell is why you need all these little things over here, which are battery management circuits. Every one of these batteries, like this, is unprotected, and if you were to discharge it below, say, about 3.6 volts, it's that the discharge curve starts to change, and it no longer is able to support the same kind of discharge rate without its temperature increasing. And you know what happens when its temperature increases too much. It loses its magic smoke and loses its magical ability. So what we have here are things like this chip, which protects a 3 to 4 series battery. These little chips here protect a 1 cell battery. This is an example here where I retrofitted a circuit that is about the size of the 18650 cell, and then you run a strip of nickel along the side and solder it to the top, and now this is a protected cell. This one happens to not work because, you know, China, but... And then this is a actual battery management circuit chip that I had made into a breakout board so I could make my own battery management circuit for a project I'm working on. And here is a actual battery pack. This is a 3S2P, 3 series, 2 parallel battery pack over here. It's using one of these battery management chips, and then it's just a barrel plug sticking out. Now, there are various ways to charge your lithium-ion batteries. Those boards don't actually handle the charging. They just handle the protection from overvoltage conditions, from low voltage conditions, from overcurrent conditions, and from short circuit conditions. That's usually just their job. So, for example, here I have a battery charger that's it's a USB-based charger, and this is a 1S4P bank here. Then you could take something like this. This is just a regular old power supply. It puts out 15 volts DC, and then this is a little Chinese circuit that takes 12 to 15 volts or whatever, and outputs the proper 4.2 volt charge for lithium-ion battery. The way these things charge without blowing them up is to bring them up to 4.2 volts under constant current at a current that is matched to the battery chemistry. So when you go and buy a lithium-ion battery, it usually comes with a charger because that charger has to be rated for the right current. Otherwise, it overcharges the battery with too much current. The battery heats up and releases its magic smoke, which you can see on YouTube is not a good idea. Likewise, when it gets overly discharged, if you're still trying to draw too much current because, your quadcopter or your RC car or your camera or whatever, it drains a pretty constant current at the correct voltage. So as that voltage drops, that current's only going up a little bit. So the chemistry can't support the current discharge at those lower voltages. So again, it overheats and blows up. But if you keep your battery in that nominal range of like 3.6 to 4.2 volts, it will discharge at its rated capacity. Now, your discharge curve could be different for your battery, so you have to know all this stuff. You have to match your battery management system to your charger and to your battery chemistry. Now, sitting over here, I have this silvery looking bag. It's silvery looking because it is fire retardant. Well, this fire retardant bag is what we're going to use later. We're going to take this battery apart. This battery has failed, and I'm going to show you what makes up one of these RC packs. That's a 4S battery. We're going to turn it into a 3S, I think. This is an individual cell charger. Focus Locust, you This is an individual cell charger that right now I'm doing a discharge test on some of my new lithium batteries, and I got a couple old nickel metal hydrides over here. So I thought we could spend some time going over some of the documents I have here, but, you know, there's a lot to this, so we're only going to be going over some of this. Like, for example, here's their complaint, which really we don't need because everything's sort of talked about in the opinion. This is an article on lithium-ion battery materials. I'm going to link to this article. I think this is a great article, but I also don't want to commit copyright infringement. So I really just wanted to show you that there are different battery chemistries made of fluorides, chlorides, I don't even know how to pronounce all of these. And they have different capacities based on how their chemistry is done. So I highly recommend that you go and read this article because I don't want to commit copyright infringement by going over a very expensive research piece on my channel. But the judge's order here really does a good job of explaining everything. And so I thought we should maybe move some things out of the way here and go over this opinion first. And then maybe we'll get to some of the other stuff that we want to do. So of course this is the Milwaukee Electric Tool Corporation versus Snap-on. The judge says this is a patent case about lithium-ion batteries and power tools. The case was tried before a jury, October 2017. The jury rendered a verdict in favor of plaintiffs and awarded nearly $28 million in damages. Before the court are the parties' post-trial motions. So this opinion is dealing with the post-judgment motions. Snap-on made some motions to get a new trial and have the judgment reversed, and Milwaukee made some motions to get post-judgment interest. The judge is going to deal with those, but in the process, we're going to get some background here, and that's mostly what I care about. In the early 2000s, plaintiff Milwaukee Electric Tools teamed up with Canadian battery maker E1 Moly to develop a lithium-ion battery usable in a power tool. Cordless power tools were traditionally powered by nickel-cadmium batteries or nickel metal hydride batteries, as lithium-ion cells could not safely or reliably produce sufficient power output for such high-power applications. In what was dubbed the 884 project, a joint team of Milwaukee and Moly scientists labored for many months to produce a working lithium-ion pack, which was finally introduced to practice in late 2002. Milwaukee's first line of lithium-ion powered tools was the V28 line, which debuted in 2005 to great acclaim. In June 2009, plaintiffs obtained patents on the lithium-ion battery pack technology they developed with Moly. The critical independent claim found in all three patents in suit recites a battery pack for powering a handheld power tool, the battery pack comprising of a housing, supportable by the handheld tool, a plurality of cells, capable of current discharge of greater than or equal to approximately 20 amps, and the cells having lithium-ion technology. The penultimate clause is known as the 20 amp limitation, and it has featured prominently in the parties' legal and factual disputes. Snap-on developed its own line of lithium-ion tools that was launched in September 2009. The case was tried by a jury October 16th. During the course of the 8-day trial, the jury was shown hundreds of documents, numerous physical exhibits, heard testimony from 24 witnesses, including 7 experts. The jury returned a verdict for plaintiffs on October 26th. The jury found that Snap-on's accused products infringed each asserted claim of the patents in suit. The jury further found that none of the subject claims were invalid as obvious, and that Snap-on's infringement was willful. Finally, the jury awarded compensatory damages, that's very important, in the form of a lump sum of about $28 million. So now they filed some post-trial motions that we're not going to go over. Instead, we're going to skip right to the most salient parts. Really, this is the biggest part here, is obviousness. Snap-on contends that the patent claims, that Milwaukee's patent claims, were obvious in light of prior art. Obviousness challenge requires showing that the differences between the subject matter sought to be patented and the prior art are such that the subject matter as a whole would have been obvious at the time of the invention to a person having ordinary skill in the art to which said subject matter pertains. So our standard here is a person having ordinary skill in the art. So that doesn't mean a lay person, that means a skilled person in the art, but having ordinary skill, not someone who is a expert in the field. To prove obviousness, one must show that the skilled artisan would have found it obvious to bridge the differences between the subject matter of the claims and the prior art. This entails a consideration of several factors, including the scope and content of the prior art, the differences between the prior art and the claims at issue, the level of ordinary skill in the art, and any relevant secondary considerations such as commercial success, long-felt but unsolved needs, and the failures of others. Patents are presumed valid, so an invalidity defense like obviousness can only succeed if proven by clear and convincing evidence. Snap-on's argument to the jury was that the plaintiff's patents simply substituted lithium-ion battery cells created by MacAulay for the NiCad cells used in existing battery packs. Everything else about the packs, including the 20 amp limitation as an industry standard, remained the same. Because of the simplicity of the change introduced in the patents, Snap-on contended that a person of ordinary skill in electronics and power tool design would have easily arrived at the same invention. The jury did not buy that argument. There was plenty of evidence introduced at trial to support that finding. First, the original prototype cells MacAulay provided to Milwaukee with a rated capacity of 15 amps did not meet the 20 amp limitation. Snap-on's own expert conceded this. Second, the later developed cells, while more powerful, did not support an obviousness claim. These cells were developed jointly by Milwaukee and MacAulay, suggesting that they were not prior art at all, since they emanated in part from Milwaukee's own work. This is true even though MacAulay's scientists were certainly the battery experts. Milwaukee's witnesses testified that they contributed performance requirements and other information based on their own expertise as battery pack designers, something MacAulay did not know about. The MacAulay contributors now believe that they did the lion's share, and that does not change anything. The jury was entitled to consider that and made their own decision. That distinguishes the case from others, such as Morgan v. Hirsch, which was cited by Snap-on, in which the parties disputed who had invented a particular thermal fabric and a method for manufacturing it. The plaintiff sought to show that he conceived of the fabric before the defendant by pointing to his work with another fabric maker. The other maker sent successive samples of product to the plaintiff, and he rejected each one until he was happy. The court found that that was insufficient to support the concept of invention. But unlike Morgan, here the evidence shows that Milwaukee and MacAulay worked closely together to develop the battery pack for the power tool. MacAulay knew battery chemistry, but did not understand that how the chemistry needed to work in a final battery pack. Conversely, Milwaukee could do little to suggest chemical changes to the battery cells. It did not passively receive MacAulay's samples. Rather, Milwaukee knew the ultimate performance requirements for the battery packs. It ensured that MacAulay's cells were tested in conformity with those standards and relayed the deficiencies in the cells as they were developed over time. If this case concerned only the development of battery cells, Morgan might be an apt analogy, but because Milwaukee made important inventive contributions to the development of the battery pack that is subject to the patents in suit, the analogy fails. Moreover, the jury apparently believed the testimony from plaintiff's experts. The jury was permitted to disbelieve Horn's assertion that other battery cells, another component of prior art, could be combined into a hypothetical pack that would meet the 20 amp limitation. He conducted no tests and provided no results to confirm his opinion. What the jury heard then was plaintiff's evidence that industry analysts saw a need for higher power, lighter cordless tools, that the V28 product line received overwhelming industry accolades, that the patented technology led to explosive growth in Milwaukee's lithium-ion sales and lucrative licensing agreements with competitors. And so the judge, having decided that the jury's verdict was sound, issued this action came before the court, presided over by Honorable Stadmuller for a trial by jury. The issues were tried, a special verdict was rendered, they've heard the post-judgment motions, and so it is ordered that plaintiffs have shown that it is more likely than not that defendants' lithium-ion battery packs infringe Claim 1 of the 290 patent, that they infringe the 173 patent, that they infringe the 510 patent. The judge then also finds that the jury's award of $27.8 million is reasonable. The judge also awards prejudgment interest. He denies judgment as a matter of law for Snap-on. He denies plaintiff's motion for additional damages, which we did not go over, and he terminates the case. Well, so then, Snap-on, having been ordered to pay $30 million, decides to appeal, and they've asked for the judge to grant them a stay of having to pay the money in the meantime. Defendant Snap-on January 10th filed a motion to stay execution of the judgment. Federal Rule 62 provides that an appealing party may obtain a stay if they post a supersedious bond. Here that would be the $30 million. The supersedious bond typically matches the amount of the judgment, though district courts have discretion. Snap-on does not want to post a supersedious bond and moves the court to waive the requirement. The court may do so. Snap-on's argument, in essence, is that it is good for the money if its forthcoming appeal should be unsuccessful. It submitted evidence showing that it has hundreds of millions of dollars in revenue and nearly $1 billion in credit. Because the $30 million judgment would be easy for Snap-on to pay, it requests that a bond be waived because it doesn't make sense. The court appreciates that Snap-on is a large, successful company, but nevertheless it will decline the invitation to waive the bond requirement. In today's world, financial health is always a fickle prospect. Depending upon the length of the appeal, Snap-on's financial position could change. Snap-on has not offered any alternative form of security to address that possibility. Posting a supersedious bond is the norm to avoid execution of judgment during an appeal. It is therefore ordered that defendant shall post the bond. And so, what just happened the other day, on the 22nd, is that Snap-on posted one supersedious bond. The bond is in the award of $35.481 million. It is posted to the United States District Court for the Eastern District of Washington. The case is being appealed. The bond is backed up by, or is, being noticed to the Travelers Insurance Company. And here is said power of attorney to act on the bond, I guess, to Travelers Insurance Company. So that's interesting. So what's in one of these Milwaukee batteries that makes it so special? Is it something special? Not really. The year is 2018 now, and we sort of understand this technology a lot better. So the way Milwaukee has chosen to make their battery packs is to put their batteries directly into this pack with no battery management circuit like that. So this battery here is just 3 of these, more or less stacked like this, in a 3 series 1 parallel configuration. And then these terminals here are 2 power terminals, and these 3 other terminals here, they carry voltage, but they're meant for referencing each cell to make sure that each cell is balanced, so that this cell has 4.2 volts, this cell has 4.2, this cell has 4.2. As it's discharging, they might get out of whack. So the battery management circuit monitors that and then trickle charges one cell to the other to make sure that they stay at the same voltage. When you buy batteries to put into a pack, you make sure that they come from the same batch. That's why I've got all those batteries over there in piles and stacks, because they were all bought at the same time, so they should all have the theoretical same chemistry and capacity and discharge curve and everything. You never ever want to mix and match batteries in the same pack, so that you never go over the capacity for the worst of them. Then what Milwaukee does is, instead of having no battery management circuit, they put their battery management circuit directly into the tool. This one, I think, has it back here in the base right before it gets to the motor. You can see the battery meter lights up when you give it a little bit of juice, and this one actually has a little LED that also lights up when the circuit turns on. But instead of taking apart a tool, because these are my tools, and honestly I don't feel like taking apart the whole tool, here, why don't we just take apart one of these, this is a battery pack adapter thing. You put the Milwaukee battery into this, and then you get an output for a heated jacket or something else. So why don't we take this part apart? In fact, we can do this with a Milwaukee drill, and that's a little bit of cannibalism, right? So that should be kind of fun. We'll turn that all the way up because that's healthy. And then let's see, I think these are just regular old Phillips head, but this may be too big. No, those are Torx. We have to get Torx. We'll be back. Yeah. All right. So here we go. And I'll latch onto that with the jaws of life here. What else we got? We got one more. And we're just knocking everything over. There we go. And that guy's probably the other thing holding that together. Let's see if we can get him out of there. How about a lineman screwdriver? I think that'll work. Yay! Lineman screwdriver worked. And there you go. Just like I said, there is a battery management circuit that is not just an output, but this will also have a low voltage cutoff on it. This one probably won't have any discharge protection or overcurrent protection because you're not supposed to be charging it in this. This is just for use with like a heated jacket. So that's really all that's for. This battery that plugs in like this, and then this provides an output. I think we can even maybe measure this output. Let me see if this guy fits here. It does. And there you go. It's a 3-cell. It's got 11.7 volts in it. And this is a little USB adapter, so it's telling me it's putting 5 volts out of the adapter. So then finally, I thought we should take a look inside one of these lithium-ion batteries and maybe show you what's involved in one of these things. Now, this is not something you should ever do at home. There's a reason why this thing is all wrapped up in fiberglass tape. And we're not going to puncture the lithium-ion battery. That's really not a good thing. So you would never want to stab or anything into this. Instead, what we want to do is open it very, very carefully so as to not stab anything in the process. Yeah, like I don't even really want to go down that side too much, lest I clip one of these packs. So taking the shrink wrap off, you can see it's 4 little plates of lithium chemistry in there, all tied together, soldered to this. One of these is dead, and all you would have to do is separate these out and then tie them back together and do that in an electrically sound way. Now, we're not going to do that here because I actually don't feel like blowing it up, but I wanted to show you what it looks like inside. This is the balance connector, which is used to sense the currents, the voltages in each one of these packs. One of these has died, and so one of these we could actually take apart because it probably wouldn't be... let's see if we can figure out which one. What do you think? Very carefully. Very, very carefully. Yeah. Let's maybe spread it with the... Maybe spread it with the spreader thing here. I'm going to guess it's this one that's all crunchy. I'm just going to guess. What do you think? What do you think? You think that's our dead cell? The one that's crunchy? I can think I can smell it. You see how they're connected in there. It has a little strip of nickel, I guess, is probably the one. Let's see. Let's get out our multimeter and see if the green lead measures 0 volts. Now we're getting 10.36, but from black to green, okay, so 3.44. That's not the dead cell. From black to yellow. Okay, so green is the first cell, yellow is the second cell, yellow is our dead cell. So what I could come in here and do safely is remove the yellow wire and remove this electrode, this connector, as well as this one. Come on. There we go. We'll nibble. And we would not really be doing anything bad if these two touched, but I'm still going to separate them like this and put this back in the bag here so it's safe and fire resistant. And we'll put that off to the side. But this is a lithium cell. This is what they look like. Where are our 2 electrodes that I cut off? I think they're up here. If I connect to one of these, positive, yeah, right. And one of these with negative, we get like nothing. We should get absolutely nothing because this is a dead cell. I just want to make sure before I keep messing with it. You know what I mean? So there's nothing in this cell. It is completely dead. So what happens to a cell when it dies? Well, these guys store their energy by having an actual chemical reaction in the cell. And over time, this chemical reaction leaves behind what's called dendrites, or little fingers going from one side of the cell to the other. And eventually those fingers touch, and when they touch, they create little short circuits, not huge ones, but little discharges, and over time those little discharges become big enough to destroy the cell. See if we can open the foil here. I'll nibble it away. You can see how pliable this is. This is why they're called lithium polymer batteries. And this is also why you don't want to pierce this, is look how flimsy and flexible this is. If you were to pierce this, you'd go right through it. There was that guy the other day who bit through one of these things for some reason. And if you did that, you'd go right through this easily. You'd press the lithium layers into each other, and you would literally start this on fire. What happens is the short circuit creates heat, the heat creates flammable gases, the gases ignite under the heat. So don't do this at home. And so last I thought we'd look at their patent, or, well, there's 3 patents in this case, but they're all similar, and so I thought I would look at really any one of them. This is the 290 patent, but you could look at the other, the 173 or the 510. I'll have links somewhere eventually. This is assigned to Milwaukee Electric Tool Company, and it's for a lithium-based battery pack for a handheld power tool. And you can see the drawing here. Looks like what we talked about, a battery pack joined with a nickel strip here, and there's a connector. If you're familiar with their power tools, this looks an awful lot like their larger size tool battery in the M12 line. I think somewhere in here they get to, electrical diagrams of battery management circuits. And this pack shows having some kind of battery management circuit in the tool, but the location of it doesn't actually affect the patent. It is my understanding that Snap-on doesn't put their battery management system in the same place, and yet it was still considered infringement. Their battery management system is in the tool pack itself, whereas Milwaukee puts it in their tools. And that's pretty much that. We've gone over the whole case, or at least the important parts of it, and why they won the case. I know that we didn't get into the actual stuff the jury had to deliberate, but it's a very, very complicated case. So hopefully you learned something today. Thank you for joining me. Thank you to our sponsor, Mr. Eevi, for sponsoring this video and supporting the channel. And thank you to all of my Patreon supporters for keeping us going as well. But between all of your support, that's really what's keeping this channel going, is because it's not YouTube. YouTube is not helping us out right now. The numbers are all over the place. They're definitely down right now. We'll go over that in another video. Thank you for joining me. I love you all. I'm Leonard French, your favorite copyright attorney. Keep your dick in a vice, and I'll see you in my next video.